So this is chapter 6. We will study simplex method, how to solve system of linear inequalities by using simplex method. You have seen in chapter 5 we are normally given some constraints like x plus y less than 1, x minus y less than 2, x plus y less than 3. So we plot all these three equations on the same graph paper. Then it is very difficult for us to locate the feasible region. And normally in real life practice we don't have only one or two equations, we may have more than three equations. In that case it would be really difficult to formulate to sketch the graph of all the equations on the same coordinate axis and also try to figure out the feasible region. So to avoid all these difficulties we develop a simplex method. Simplex method, this is some history about simplex method. This is the person I think who introduced the simplex method. Again, some history you can go through from it on your own. And okay, here comes the standard maximization problem. You will be given an objective function like p equals to x1 x2. Here 1 and 1. In this case c1 is 1, c2 is 1, and then you will be given some constraints. Always all the constraints will be in less than equals form if it is standard maximization problem. Maybe you will have constraint 2x1 3y less than 3, x1 minus y less than 4, 2x1 3x2 less than 3. Here we can write x2 and x2 like x2 and x2. So you will be given three constants or more than three constants or maybe less than three constants. All the inequalities are in less than equal form and an objective function. Then it is called standard maximization problem. Now you can see this is the standard maximization problem. You are given one objective function and all the constants are in less than equal form. All the constants are in less than equal form. So there are four lines bordering the feasible region. Any two of them intersects in a point. There are total of 6 such points. When you do this you will figure out all this explanation. The coordinates of the points can be found by solving the system of two equations into two unknowns created by the equations of the two lines. Some of the points are corner points and the feasible region, and some are outside the feasible region. And that is a practice which we used to do, but it is quite messy. So we try to figure out a new method which is called simplex method. You see, this left side is less than right side, so it means that we need to add something to make them equal. It is exactly like this: 4 is less than equals to 5, so I want to add something here on the left side to make it equals to 5. So it is similarly here we are adding some number slack variable, we call it slack variable s1 to make them equal. So you can see now we can write equal. Similarly for equation 2, it is also the left hand side is less than the right hand side, so we add some slack variable s2 to make them equal. So this s1 and s2 is called the slack variable. So now we have four unknowns: x1 x2 s1 and s2 are so called x and y. We make the system have a unique solution by assigning our basic variables equals to 0, sorry, non-basic variables equals to 0, and we can get the solution for our basic variables. This is a general explanation, we can discuss it later. If you assign value 0 to our non-basic variables, non-basic variable, we always assign value 0 to our non-basic variables. Don't forget this point, I repeat it, we always assign value 0 to our non-basic variables. I will explain it later in this slide which one is basic variable and which one is non-basic variable. So here you can go through from this slide, it is not necessary to waste the time on it. Now I jump into the section 6.2 and we will see how we can apply simplex method after adding the slack.